Hey guys, and welcome back to a new video. In this video, before moving into any more topics related to Android, I wanted to discuss with you the advanced usage of the ViewModel class. When I say advanced usage, I mean how to pass arguments to the ViewModel and how to listen to data changes of the field within the ViewModel class. So let's look at our initial setup for this project. Here we have a main activity with this layout. So I have a fragment container view to show the fragment. Then comes a guideline set to 50% of the screen, and finally a text view here within the main activity. You can notice also that the text view is by default doesn't have any text. I used the tools attribute only to show the text at design time. And here within the main activity code, you can see I created an instance of the first fragment, which we are going to look at in a moment. Then I use the fragment manager and the fragment transaction APIs to add the fragment to the fragment container view. And here, our first fragment, just a plain fragment. I already set up the binding. And finally, the layout of the first fragment has an edit text and a button. Whenever we click on that button, the edit text here, or the text within the edit text, is going to be set to the text view within the main activity automatically without having to do that whenever we click on the button. And we are going to see how would this work. Now, before everything, let's create our view model. So here, click new class. I'm going to name it app view model. Let's make it extend the view model class, add the constructor, and let's see how we can pass arguments to the view model. So to pass arguments to the view model, you could simply do it by opening the constructor like you would do it with any other class. So let's say we want to pass the context to access some resource within our project. And by default, view models don't have access to the context because they don't resemble a screen or a UI element within our app. They're only plain helper classes. So here we are going to pass the context. And now whenever this view model is initiated, we want to access some string resource from our project here. So let's add the init block, which is going to be called or executed whenever this view model is initiated. So use the context dot resources dot get string, and within our resources here we have a bunch of dump data or bunch of dump strings. So let's use the app name, for example. So here are dot string dot app name, and whenever this class is initiated, we want to set this app name to some kind of variable here. So let's create a variable var string text. Initially is an empty string, and here string text equal to that. Now let's go to the main activity to see how we would initiate a view model with arguments. So just underneath the support fragment manager, like before, val view model is of type app view model equal to view model provider. This is the owner, and finally call get. I'll tap to import the extension function. Now, if you run the app would crash because the app doesn't know how to initiate or initialize the view model that you created with arguments. So you need to pass the context to the view model. But how we can do this? Well, view models are managed by something called ViewModel Factory, which takes care of initializing and creating your view model if it's not created, and also takes care of providing the same instance of the view model that has the same owner. Like for example, here we have the main activity as the owner. And if you go to any fragment that is hosted by the main activity and try to create a view model and pass the main activity as the owner, then we are going to get the same instance. So you can see here, if you press Ctrl P after the owner, you can see that it can take a view model factory. Now we are going to create a class that extends the view model factory and then pass the context to that class, and finally pass that factory to our view model provider constructor. Feel free to create the factory anywhere in your code. Just for convenience, I will create it within our app view model. So here, underneath the view model, let's create that factory. So I'm going to create a class called app view model factory. And here we are going to pass the same arguments that we passed to the view model. So in this case, we are passing a context. And finally, let this class extend the view model provider dot factory, which is the interface within the view model provider. So here, after you created the class, click Ctrl O and override the create function. You can see here the create function might look some kind of complex, but let's break it down into pieces. The first thing that you can notice is just an overridden function. And here you can see the generic type. It says that the generic type should extend the ViewModel. And this function is called create, as it creates the ViewModel. Now you can see it also takes some value of type class that has the same generic type, and finally returns the generic type, which is the ViewModel. So how we can pass this context to our ViewModel so we can initialize it within our main activity? Well, the code is going to be pretty much the same for any ViewModel that you create. So the first thing is that you are going to check if the ViewModel is assignable from this factory. So here I'm going to use the model class dot is assignable from. Here you're going to pass the type of your main activity. Here you're going to pass the type of the ViewModel. So app ViewModel ; class.java. If this is the case, then we return app ViewModel, and here we are going to pass the same context that we have within our constructor. Now we cannot access the context directly within a function, so let's make it a file. And since we are using it within this class, let's just make it private so we prevent outside access. Context equal to context. The last thing, we have to cast this to the generic type, which is t. And if this is not the case, then let's just return null or through some exception. So for this case, I'm going to throw some kind of exception which doesn't actually occur. So let's do that to prevent compile time error. Illegal argument exception. Now the code might look so much complicated, but don't worry, it's going to be the same code that you would use with any ViewModel. The only thing that you have to change is the name of the class, which just has the name of the ViewModel, the type of the ViewModel. If you have some kind of maybe main ViewModel or fragment ViewModel, then you are going to change the type and the name. And lastly, the last thing you would change is the arguments. So if you are passing more than one argument, you are going to change that and pass the arguments to the ViewModel. Now, let's go back to the main activity. And here, before creating the ViewModel, we are going to create an instance of the ViewModel factory. So ViewModel factory equal to app ViewModel factory. And here we have to pass the context. So pass this as the context, or you could simply pass application context. And here, you're going to pass the same instance of the factory to the ViewModel provider. And that's it. Whenever you have a case when you have to pass arguments to the ViewModel, simply create the ViewModel with arguments, then create the ViewModel factory and pass your arguments here, then create the instance of that and pass it there. And lastly, create your factory and pass it to the ViewModel provider. Now, let's set the text within the main activity to the text within our ViewModel. So binding.mainActivity.text equal to ViewModel.string text. And if you noticed that the text within our main activity doesn't have any text initially, only a text set with tools, so it will only appear at design time and not at runtime. Here, if we run, we should see the app name from our project resource. Let's run to see how this works. So here you can see the ViewModel factory is created, then the ViewModel is created, and we got the text from the ViewModel, and the text is set to the main activity text view. Now let's move to the case where we want to listen for changes on the data within our ViewModel and update the UI accordingly. So here I'm going to go to the first fragment class, and I'm going to create the same instance of the ViewModel with the same owner. So I'm going to pass the activity or the main activity as the owner. Let's override the onCreate. Here I'm going to make the ViewModel variable as a field. So private val ViewModel is of type app ViewModel, or let's make it a private late init var. And here within the onCreate ViewModel equal to ViewModel provider, pass main activity as the owner, require activity, and finally call get. So now you can notice we didn't pass the factory here. We didn't have to create an instance of the factory and pass it to the ViewModel. Well, as we have said before, the ViewModel factory takes care of creating the ViewModel. And since you are passing the same activity or the same activity which has already an instance of the ViewModel, then it will get you the same instance of the ViewModel without having to pass the factory. But if you, for example, are creating this ViewModel only for this fragment, for example, you're going to pass this as the owner, Then you have to pass the ViewModel factory, which you are going to absolutely create an instance of, and failing to do so will lead your app to crash. So here, again, let's take a look at our fragment layout. And what we want to do is whenever we click on this text, we want to set the text within our ViewModel to the text of the edit text right here. So let's do that within the onViewCreated binding.firstFragmentPTN.setOnClickListener. Here we are going to set the ViewModel text or the ViewModel variable to the value of the edit text. But how we can do this? Well, if you take a look at the string within our app ViewModel, it's just a field of type string. And to make our UI or make our UI classes listen to changes of this field, we have to make this string or this variable of type live data. And if you're wondering what is a live data, it's just an observable data holder classes that respects the lifecycle of other UI components, such as activities or fragments. It automatically updates the UI components whenever the data change, just like the data types that we use with the data binding. So here, instead of making a string, let's make it immutable live data. Here you can pass initial value or simply specify the value of this live data. So here, since we made this a live data, we are not going to change the variable or reassign the variable. We are going to reassign the value within this mutable live data. So let's make this as a val. And here, to update the value of the mutable live data, use .value. So this value here represents the value string within the mutable live data. And whenever this value string changes, then the UI will change accordingly. Now to reflect these changes, let's go to the first fragment. And we said whenever we click on the button, we want to update the text, then the ViewModel. So ViewModel dot string text dot value is going to equal to binding dot first fragment edit text dot text dot to string. And now let's go to the main activity to make our main activity observe or listen to changes on that field. So for this, we have to call ViewModel dot string text dot observe. And here, observe will keep listening to the changes on this field. The first thing we have to pass is a lifecycle owner. So pass this activity as a lifecycle owner. And finally, you're going to have a lambda that passes the value or the new value of that field. So let's get this within the lambda. And whenever this changes, we want to update the text view within our main activity to the text that comes from the string text variable. And now let's run to see how would this work. So here you can see if you try to change the edit text within our fragment, ASD, and click on change text, you can see that the changes of the text automatically reflect on the main activity without having to add some kind of functionality to the change text button within our fragment to change the text within our main activity. So the main activity simply listens to every change that happens on this variable, which is of type mutable live data of type string, and updates the UI accordingly. You could also have multiple live data of multiple types, integer or any primitive type, or any object type like your custom classes. Now, for convenience, the immutable live data is always set to be private. So we have to prevent outside access of this mutable live data. And the way to make this accessible or editable from outside is to create a function. So here we are going to create a function to edit this live data just underneath the init. I'm going to call it fun edit text. Takes a text from outside, so string is of type string. And here it updates the string text dot value to the text passed from outside of the ViewModel. Now, since we made this private, we cannot observe the value of the string text. So for that, we have to create another variable and make it public. And this is going to be of type live data only. So it will not be mutable, it will not be editable, it will only be there for observation. So let's import that. And since both have the same name, let's make the private one with an underscore or prefixed with an underscore and make this as it is. Now, we have to always set the value of the public field to the value of the private field. So let's make this here is going to be of type live data of type string and make it equal to string text. Now here, any class outside of the ViewModel will never ever have the ability to change the value of this live data. So if you try to do this, you can see here we're going to have some kind of compile time error saying that the value of the mutable live data cannot be reassigned. So that means when we try to update the value within our first fragment, we are going to have this error. And that's why I created this function to update the value of the ViewModel. So ViewModel.edit text, and here pass this text to the edit text function, and it will accordingly update the value of the ViewModel, and the main activity will listen to its changes just as before. Now, for the live data, we also have another type of observable types or observable data holders, which are called flows. But we are not going to discuss them in this video, because using flows require knowledge of how to use coroutines or multi-threading in Kotlin, which we haven't discussed in this series yet. So mutable live data are just fine to use for now, as they respect the lifecycle of the UI components. So that means they will always listen to changes of the values as long as the ViewModel is visible to the user. And whenever the user leaves the app or leaves the screen that is observing some value, then it will stop observing the value and will save the memory that could be wasted by observing the data that are not visible to the user. So that was it for this video. Thank you for watching, and I hope to see you in the next video.